What if the universe is far more terrifying than we ever imagined? We gaze up at the stars with wonder, finding beauty in the constellations and comfort in the familiar glow of the moon. But beyond that serene canvas lies a reality far stranger and more menacing than our minds are built to comprehend. The cosmos isn't just beautiful, it's alive with forces so bizarre, so utterly alien, that they defy everything we think we know about reality itself. This isn't science fiction. These are the chilling truths hiding in plain sight, just waiting for us to look a little closer. Today, we're venturing into the great unknown to uncover 25 of the most terrifying things in space phenomena that will make you reconsider the night sky. From black holes that warp the fabric of time to invisible entities that could be watching us right now, each entry on this countdown challenges not only our understanding of the universe but our very sense of safety within it. This is a journey into the shadows of creation, where the laws of physics twist into nightmares and the silence of space echoes with possibilities too frightening to ignore. You're about to witness cosmic horrors that lurk in the darkness, entities and events so powerful and bizarre, they seem pulled from the darkest corners of imagination. Yet they're real, and as we count them down one by one, you'll begin to see the universe not as a peaceful expanse, but as a place brimming with unanswered questions and unimaginable dread. So take a deep breath and steady your nerves. What you're about to discover will forever change how you see the stars. We begin our countdown with a predator so stealthy, so utterly dark, it could be passing through our solar system at this very moment, and we might not know until it was too late. These are not the stationary black holes anchored at the centers of galaxies. These are the rogues, the loners, the nomads of the cosmos, black holes that have been catapulted away from their birthplaces by violent galactic collisions, sent drifting silently through the void. Picture an object with the mass of 1,000,000 suns, compressed into a point of infinite density, its gravitational pull so intense that not even light can escape its grasp. Now imagine that same object, completely invisible, moving through the galaxy at hundreds of thousands of miles per hour. It is the ultimate cosmic ghost, leaving no trace of its journey except for the devastation it leaves in its wake. The true horror of a rogue black hole isn't just its immense power, but its perfect camouflage. We can only detect most black holes indirectly by observing the frenzied, high-energy X-rays emitted by the hot gas of an accretion disk as it's torn apart and consumed. But a black hole wandering alone in the empty space between stars has no such dinner plate. It is fasting, and in its hunger it gives off no light, no radiation, no signal at all. It is a bottomless pit moving through the darkness, utterly undetectable with our current technology, until it gets close enough to begin warping the fabric of space-time itself. This isn't just theoretical. Astronomers have already found evidence of these free-range horrors, using a technique called gravitational microlensing, where the immense gravity of an object bends and magnifies the light from a star behind it. Scientists have spotted what they believe are stellar mass black holes roaming our galaxy. But what if there are larger ones, intermediate or even supermassive black holes on a solitary path? The approach of such an object would be deceptively subtle at first. The first sign might be a slight, unexplained wobble in the orbits of the outer planets, a perturbation in the serene dance of our solar system. Then the Oort cloud, that vast, icy shell of comets at the very edge of our sun's influence, would be stirred into a frenzy. This connects to a chilling hypothesis known as the Nemesis theory, which proposed a dim companion star to our sun responsible for periodic comet showers that cause mass extinctions on Earth. While the star Nemesis was likely never there, the mechanism is sound. A rogue black hole would be a far more effective and terrifying nemesis. Its gravity would act like a colossal fishing net, hurling countless icy comets and dwarf planets inward toward the sun, a cosmic bombardment with our fragile world directly in the crosshairs. Long before the black hole itself arrived to feast on our planets, its gravitational wake would have already sent cataclysmic impactors screaming toward Earth, an unavoidable rain of fire and ice heralding the arrival of an invisible god of chaos. But our nightmare tour of cosmic dread has only just begun, because the terror is not always something we can point to in the sky. Sometimes the most profound threat is woven into the very fabric of reality itself. An existential danger that could erupt from the empty space between stars, triggered by nothing more than a random quantum fluctuation. This is the theory of vacuum decay, a hypothesis so catastrophic that it posits the entire universe could be fundamentally unstable, sitting on a precarious ledge just waiting for the slightest nudge to send it tumbling into the abyss. To understand this, we need to rethink what we mean by nothing. The vacuum of space is not truly empty. It's a seething, bubbling quantum foam full of transient particles popping in and out of existence. Physicists describe this vacuum as having a certain energy level, a ground state. The unsettling idea behind vacuum decay is that our universe might not be in the true, lowest possible energy state. Instead, we might be existing in a false vacuum, a kind of metaphoric valley perched high in the mountains. The true vacuum, the actual lowest energy state, would be the ocean far below. Our universe is stable for now, sitting comfortably in this valley, but it's a precarious stability. All it would take is a quantum event with enough energy to push a tiny portion of the universe over the mountain pass and into the lower valley. This event would create a microscopic bubble of true vacuum. This bubble wouldn't just sit there. The laws of physics as we know them are a product of our current vacuum state. The true vacuum would have completely different fundamental constants. The force that holds atoms together, the speed of light, the very charge of an electron, none of it would be the same. And because this new state is more stable, it would be energetically favorable for it to expand. This bubble of new reality would surge outward in all directions at the speed of light. The wall of this expanding sphere would be a wave of total annihilation, not in an explosive sense, but in a far more absolute one. It wouldn't blow things up, it would simply rewrite them. There would be no warning, no flash of light, no sound. One moment the universe exists as we know it, the next nanosecond the wavefront passes through our region of space. Every atom in your body, every planet, every star in its path would cease to function under the old rules. The very building blocks of matter would unravel instantly and painlessly, reconfigured into something entirely new and unrecognizable. Life, consciousness, matter itself, everything that defines our existence would be erased from the cosmic record, replaced by a new universe operating under alien laws we cannot possibly predict. The entire history of our cosmos, every achievement and every memory, would be rendered null and void in an instant. The most frightening aspect is the trigger. This catastrophe wouldn't require a stellar collision or a supernova. It could be sparked by a random, spontaneous quantum event anywhere in the universe. It could have already happened billions of light years away, and the sphere of oblivion could be on its way to us right now, expanding at light speed. Because it moves at the ultimate speed limit, we would have absolutely zero warning. The first and last thing we would ever know about it is the end of everything. But if the silent, creeping dread of vacuum decay represents an end to physics itself, our next entry is a far more visceral and explosive apocalypse. It is the universe's ultimate flashbang, a detonation of pure energy so violent it can outshine entire galaxies. These are gamma-ray bursts, and they are the single most powerful explosions since the Big Bang. In the span of just a few seconds, a single gamma-ray burst can release more energy than our Sun will emit across its entire 10 billion-year lifespan. It is a weapon of mass destruction on a cosmic scale, and if one were to target Earth, it would unleash an extinction event that makes asteroid impacts look trivial. The genesis of these monstrous events is often tied to the death of massive stars. When a star many times larger than our Sun exhausts its fuel, its core collapses not into a quiet white dwarf, but into a black hole or an ultra-dense neutron star. This collapse happens in an instant, launching twin jets of plasma and radiation out of the star's poles at nearly the speed of light. These jets, focused and narrow, are the gamma-ray bursts. For their terrifying power to be felt, a planet must be unfortunate enough to be looking directly down the barrel of one of these celestial guns. The difference between witnessing a spectacular light show and being utterly annihilated is a matter of alignment. The effects on a planet in the direct line of fire are horrifyingly systematic. The first wave is the initial blast of gamma rays and X-rays, lasting from a few milliseconds to several minutes. This radiation would slam into our atmosphere with the force of a nuclear bomb, detonating over every square inch of the planet. It would instantly ionize the upper atmosphere, breaking apart the molecules of our protective ozone layer and literally cooking the nitrogen and oxygen to create a thick smog of nitrogen dioxide, a toxic, brownish gas that would shroud the planet in a perpetual dark twilight. Our first and most vital shield against the Sun's own ultraviolet radiation would be obliterated in a flash. The second act of this tragedy would be just as lethal. The high-energy radiation would break apart atmospheric molecules, triggering a chain of chemical reactions that would create nitric acid rain. This acid rain would pour down for days or weeks, poisoning oceans and lakes and scorching the land and any life on it. But the final, lingering death blow would be the relentless ultraviolet radiation from our own Sun, now unimpeded by the vanished ozone layer. This UVB and UVC radiation would penetrate the surface, causing severe sunburns in minutes, blinding animals, and destroying the base of the food web by killing phytoplankton in the oceans and stunting plant growth on land. The entire ecosystem would collapse from the bottom up, leading to a mass extinction that would make the dinosaur-killing asteroid look like a minor inconvenience. We know this isn't just theoretical doom-mongering because we have witnessed the raw power of these events from a safe distance. In March 2008, astronomers observed a gamma-ray burst designated JAB 080319b. It occurred in a galaxy 7.5 billion light-years away, yet for about half a minute, it was visible to the naked human eye here on Earth. This means an explosion so incomprehensibly far away that its light had been traveling for half the age of the universe was briefly brighter than the faintest star you can see on the darkest night. If a gamma-ray burst of that magnitude happened within our own galaxy, even thousands of light-years away, and its jet was aimed at us, the consequences would be immediate and irreversible. It is a sobering reminder that we exist in a cosmic shooting gallery, where the universe occasionally demonstrates its ability to erase us with a flick of its wrist. Yet for all the terrifying power of a gamma-ray burst, at least it is a known quantity, a phenomenon we can observe and measure from a safe distance. Our next cosmic terror is something far more enigmatic, a mystery that pulls at us from the shadows of the universe itself. Imagine you're drifting in a boat on a vast, calm river. The water is still, the air is quiet, but you feel an unmistakable current tugging you forward. You paddle against it, but the pull is relentless, drawing you toward a horizon you cannot see, toward a destination that is completely hidden from view. Now scale that feeling up to a galactic level. This is the experience of our entire Milky Way galaxy, caught in the irresistible gravitational current of a cosmic mystery we call the Great Attractor. Located in the general direction of the constellations Centaurus and Norma, roughly 220 million light-years away, lies something with the gravitational pull of tens of thousands of Milky Ways. This invisible behemoth is dragging our galaxy, along with our entire local group of galaxies and the entire Virgo supercluster, toward it at an incomprehensible speed of 14 million miles per hour. We are caught in a cosmic river flowing toward a waterfall we cannot see. The sheer scale of this force is humbling. It overpowers the expansion of the universe itself in our local region, bending the paths of galaxies to its will. The profound fear this instills isn't just about its power, but about our inability to see it. The Great Attractor lies directly behind the plane of our own galaxy, a region astronomers call the zone of avoidance. Here, the thick dust, gas, and dazzling stars of the Milky Way's central bulge create an impenetrable cosmic curtain, blocking our view of the universe beyond in optical wavelengths. For decades, this was our collective blind spot, a place where we knew a monumental secret was hidden but could not peer through the veil. It was the ultimate cosmic tease, a gravitational siren's call emanating from a place we were forbidden to see. This forced a technological detective story. To unravel the mystery, astronomers had to become cosmic spies, using telescopes that see the universe in different kinds of light. Using radio, infrared, and X-ray observatories, they began to peer through the galactic fog. What they found behind the curtain was both a partial answer and a deeper mystery. The Great Attractor isn't a single, monstrous object waiting to devour us. Instead, it appears to be the heart of an immense superstructure known as the Laniakea supercluster, of which our own Virgo supercluster is merely a sprawling suburb. Laniakea, Hawaiian for immeasurable heaven, is a galactic filament, a web of hundreds of thousands of galaxies all bound together by gravity, with the Norma cluster at its densest central core. This discovery should be comforting. We're not being pulled toward a single devourer of worlds, but are simply part of a vast, flowing cosmic metropolis. And yet, the deeper terror remains. The initial pull of the Great Attractor was so strong that scientists realized even the immense mass of the Laniakea supercluster might not be enough to account for it all. This suggests that something even larger and more massive might lie beyond it, an even greater attractor pulling on the Great Attractor itself. We are like ants on a log floating down a river, only just realizing the log itself is in a current heading toward a waterfall we can't even comprehend. The true source of this motion may be structures so colossal they defy our current understanding of the universe's large-scale structure, hinting at forces and formations we have not yet even begun to imagine. But just as we begin to map the grand currents of the cosmos, we discover that the true horror isn't always in the vast, unseen structures pulling at galaxies. It can also lurk in the intimate, binary dance of death between two stars. Imagine a celestial vampire, a corpse that refuses to stay dead. This is the reality of a Type Ia supernova, a cosmic detonation born from a stellar resurrection so violent it can outshine an entire galaxy. The protagonist of this horror story is a white dwarf, the dense, Earth-sized core of a star like our Sun that has exhausted its nuclear fuel and died, slowly cooling over billions of years into a dark crystalline diamond. This should be its final, peaceful end. But if this dead star has a living companion, a red giant or a main sequence star locked in a gravitational embrace, its quiet retirement becomes a nightmare. The white dwarf's immense gravity begins to siphon hydrogen and helium from its partner, pulling a stream of fresh fuel from the living star onto its own inert surface. This stolen matter accumulates, building up layer by layer. With each passing moment, the corpse gains mass, pressing inward on its core. For a time, this seems like a second chance at life. But this is no rebirth. It is a Chinese letter, a trap set by the laws of physics. The white dwarf has a strict limit, a boundary from which there is no return, known as the Chandrasekhar limit. This is approximately 1.4 times the mass of our Sun. As the dead star approaches this critical threshold, the pressure and temperature at its core become so astronomically high that they trigger a cataclysm we can scarcely imagine. Carbon fusion, a process that had shut down eons ago, suddenly reignites, but this is not the stable, life-giving fusion of a main sequence star. This is a runaway thermonuclear explosion that rips through the entire white dwarf in a matter of seconds. There is no collapse, no remnant left behind. The entire star, every atom is completely and utterly annihilated in one of the most energetic events in the universe. The resulting flash of light is so brilliant, so uniform, and so predictable that astronomers use these explosions as standard candles to measure vast cosmic distances and discover the universe's accelerated expansion. This same tool for discovery is also a monument to annihilation, a phantom limb in a binary system where one star is completely erased, its partner left reeling from the blast. The terrifying beauty of this process is its perfect consistency. Because the detonation always happens at the same mass threshold, the luminosity of every type Ia supernova is nearly identical. This allows scientists to measure how far away they are with incredible precision by simply noting how bright or dim they appear to us. It was by observing these very supernovae that astronomers made the shocking discovery that the universe's expansion is not slowing down as everyone expected, but is actually accelerating, propelled by the mysterious force we now call dark energy. So, in a deeply ironic twist, these violent stellar deaths, these ultimate acts of cosmic destruction, have become our most important beacons for understanding the fate of the entire cosmos. They are both the end of a star and a key to the beginning of a new chapter in physics, a haunting reminder that even in death and chaos, the universe holds profound and often unsettling secrets. Yet for all the terrifying structure and violent death in the cosmos, perhaps the most profound horror lies not in what is there, but in what is not. Imagine the deepest, most silent ocean trench on Earth, but then scale that emptiness up to a canvas so vast it could contain thousands of Milky Way galaxies with room to spare. This is the Boötes Void, a spherical region of space so incomprehensibly empty that it has earned the far more chilling nickname, the Great Nothing. Located about 700 million light-years from Earth in the constellation of Boötes the Herdsman, this void is not just a slightly less crowded neighborhood. It is a cosmic desert of staggering proportions, approximately 330 million light-years in diameter. To truly grasp that scale, consider that our entire local group of galaxies, including Andromeda and the Milky Way, is only about 10 million light-years across. You could drop over 30,000 of our local universes into the Boötes Void and still have room to spare. Within this unimaginable volume, astronomers have found only about 60 galaxies. In a region of space that should statistically contain well over 10,000 galaxies, there are merely a handful. It is a vacancy so extreme it feels intentional, as if some cosmic architect simply forgot to fill in this part of the blueprint. The existential dread this void inspires is unique. A black hole is terrifying in its active, predatory consumption. A gamma-ray burst is horrifying in its violent, explosive power. But the Boötes Void is terrifying in its passive, absolute absence. It is the antithesis of creation, a monument to nothingness. Gazing into it is like staring into a bottomless well of darkness and realizing the universe is not just full of things, but is also defined by immense, gaping holes of nothing. It challenges the very principle of cosmology that, on a large enough scale, the universe should appear roughly the same everywhere. The Great Nothing is a glaring exception to that rule, a silent anomaly that whispers that our understanding of the universe's structure is still in its infancy. The leading theory for its existence is almost as unsettling as the void itself. Some cosmologists suggest it could be the result of countless smaller voids merging over billions of years, like soap bubbles coalescing into one giant bubble. Others have proposed a far more dramatic origin, that the Boötes Void could be the imprint of a collision between our universe and another parallel universe in the multiverse, a scar left on the fabric of reality from a brush with another cosmos entirely. While this remains highly speculative, the very fact that such a fantastical idea is even considered highlights how deeply this great nothingness perplexes and unnerves those who study it. To be a hypothetical civilization inside one of the void's lone galaxies would be a fate of profound isolation. Their night sky would be almost perfectly black, devoid of the faint, fuzzy blobs of neighboring galaxies that dot our own heavens. They might look upon their own single galaxy and believe it to be the entirety of creation, with no external clues to the vibrant, galaxy-filled universe that exists beyond their dark, immense prison walls. They could develop an entire science and mythology based on a lonely, island universe, completely unaware of the cosmic community they are missing. Theirs would be a universe of silence and darkness, a thought that makes our own crowded galactic neighborhood feel like a bustling metropolis in comparison. Yet for every cosmic structure that pulls matter together, there exist equally powerful forces of expulsion, casting objects out into the eternal dark with unimaginable violence. If the Boötes void represents a place of terrifying absence, then hypervelocity stars are the terrified refugees fleeing into that emptiness. These are not your average stars drifting placidly along their galactic orbits. These are celestial cannonballs, lone suns that have been violently flung out of their home galaxies at speeds exceeding 1 million miles per hour, sentenced to an endless journey through the cold, empty void between galaxies. The story of their exile begins with one of the most terrifying objects we've already discussed, the supermassive black hole. At the heart of most galaxies, including our own Milky Way, lurks one of these gravitational monsters. Often they exist in binary pairs, two black holes locked in an orbital dance after their host galaxies collide. When a wandering star ventures too close to this chaotic duo, a gravitational game of cosmic pinball ensues. In a mechanism known as the Hill's mechanism, one of the black holes can capture the star while the other acts like a slingshot, flinging it away at a significant fraction of the speed of light. The forces involved are beyond human comprehension. The star is essentially ripped from its galactic moorings by the pure, Chinese letter gravity of space-time itself. Alternatively, a supernova explosion in a tight binary star system can act like a natural catapult. If one star explodes asymmetrically, the sudden loss of mass can release its companion from their gravitational bond, ejecting it at tremendous speed like a stone from a sling. The aftermath of this ejection is a fate perhaps more lonely than any other in the universe. Imagine our own sun, suddenly and without warning, accelerated to over 1,000 kilometers per second. In a blink, the familiar constellations would vanish. The warm glow of the Milky Way would recede into a faint, fuzzy patch of light and then disappear entirely. The star would leave behind everything it has ever known, its sibling stars, its planetary systems, its entire galaxy, to be cast adrift in the intergalactic medium. For millions, then billions of years, it would travel through a space so empty that the next atom it encounters might be light years away. Its light, which once contributed to the grand tapestry of a galaxy, would now shine uselessly into the abyss, illuminating nothing forever. Any planets that managed to stay bound during this violent ejection would face an even grimmer fate. They would be orphaned along with their star, but their world would slowly freeze over as they drift further from the heat of any other sun, the star's light becoming a solitary lantern in an infinite sea of black. The discovery of these stars here in our own galaxy serves as chilling proof of this violent process. The first hypervelocity star was discovered in 2005, a young blue star moving so fast it had the escape velocity to break free from the Milky Way's gravitational pull entirely. Since then, dozens more have been found, each one a silent testimony to a past encounter with unimaginable forces. They are the cosmic equivalent of a message in a bottle hurtling through the void. Their very existence maps the hidden violence at the heart of our galaxy, telling a story of gravitational interactions so powerful they can turn a star into a permanent exile. They are a reminder that even the seemingly fixed and steady lights in our sky are subject to the universe's capricious and terrifying power, capable of creating not just voids of space, but voids of connection, sentencing entire solar systems to an eternity of unimaginable isolation. Yet even as we chart the courses of these stellar exiles, we discover a motion far more vast and unsettling than any single star could ever achieve. It is a current that moves not stars, but entire clusters of galaxies, pulling them in a coordinated stream toward a point on the edge of nothingness. This phenomenon is known as dark flow, and it suggests a terrifying possibility that the structures we see and map may only be a small part of a much larger reality, and that something unimaginably immense beyond the edge of our observable universe is pulling on everything we can see. The story of this discovery begins with the cosmic microwave background radiation, the faint afterglow of the Big Bang that fills all of space. This ancient light is the most perfect natural reference frame we have, a snapshot of the infant universe. By studying tiny variations in its temperature, scientists can measure our solar system's motion through the cosmos. We're moving at a certain speed relative to this background. This is expected, but in 2008, a team of astronomers led by Alexander Kashlinsky made a profoundly strange observation. They were studying the motion of enormous galaxy clusters by looking at the way the cosmic microwave background light was distorted as it passed through them, an effect known as the kinematic Sunyaev-Zeldovich effect. What they found was not just random motion. They detected a startling, coherent flow. Hundreds of galaxy clusters spread across billions of light-years were all streaming in the same direction at velocities exceeding 1 million miles per hour. This wasn't just a slight drift, it was a cosmic tide, a synchronized movement of thousands of the largest structures in the universe. The most baffling part was the source of this pull. The direction they were flowing didn't point toward any known massive superstructure within our observable universe. Nothing we can see has enough gravitational influence to orchestrate this motion. The pull was coming from something beyond our cosmic horizon, from a region of space whose light has not had enough time since the Big Bang to reach us. This is where the true terror of dark flow takes root. The observable universe is a sphere centered on us with a radius of about 93 billion light-years, representing everything we could possibly see. But most cosmologists believe the entire universe is much, much larger, perhaps even infinite. Dark flow implies that the distribution of matter does not end at the boundary of our observation. Instead, it suggests there are structures of incomprehensible scale, superclusters, or concentrations of mass so huge they defy imagination residing in the unobservable universe. These structures are so massive that their gravitational pull reaches across the void, influencing the motion of galaxies within our own visible cosmos. We are like deep-sea fish sensing the tidal pull of a moon we can never see, a force acting upon us from a realm forever hidden. The implications are staggering. It could mean our universe is far more inhomogeneous on the largest scales than we ever thought, with vast, unseen continents of matter and equally vast empty deserts. Some have even proposed more radical explanations, such as the gravitational influence of another universe entirely, a parallel cosmos in the multiverse brushing up against our own and tugging at the fabric of our reality. Whether the cause is a colossal structure or a collision of universes, the phenomenon of dark flow suggests we are not the center of anything, but merely a small neighborhood influenced by a metropolitan area that lies permanently over the horizon, its skyline forever hidden from our view. It is the ultimate cosmic humility, a reminder that we are not just living in a universe full of secrets, but that we are confined to a tiny room within an infinite mansion, listening to the faint, unsettling sounds of movement coming from the halls beyond our locked door. But this grand and terrifying silence, this absence of calls or visitations, leads us to one of the most profound and unsettling questions in all of science. It's a question first posed informally by the physicist Enrico Fermi over lunch one day in 1950, and it has echoed through the decades with growing urgency. The universe is incomprehensibly vast and staggeringly old. Our galaxy alone contains hundreds of billions of stars, and many of them are billions of years older than our Sun. The raw numbers suggest there should be ample time and opportunity for countless civilizations to have arisen, to have explored, and to have colonized the entire galaxy. The mathematics of it seems inevitable, and yet when we train our radio telescopes on the heavens, we are met with nothing but a crushing, empty silence. Where is everybody? This is the Fermi paradox, and the possible answers to this simple question are more terrifying than any monster we could ever invent. One of the most prominent and chilling solutions is known as the Great Filter hypothesis. This theory suggests that the evolution of life from its origins to a spacefaring, galaxy-spanning civilization requires the passing of a series of incredibly difficult evolutionary and technological steps. The Great Filter is that one, nearly insurmountable barrier that prevents almost every species from achieving interstellar travel. The true terror of this idea lies in its location. Is the Great Filter behind us? Did we, through some miraculous fluke, already pass a stage that eliminates virtually all other life? Perhaps the jump from simple prokaryotic cells to complex eukaryotic cells was so astronomically unlikely that it almost never happens, making every complex organism in the galaxy a breathtaking rarity. If that's the case, we are alone, and the universe is a beautiful, empty museum waiting for us to be its curators. That is a lonely and profound thought, but it is not the most frightening possibility. The true nightmare scenario is that the Great Filter is not behind us, but ahead of us. This suggests that the development of a technological civilization inevitably leads to its own destruction. Every time a species reaches our level of advancement, it discovers the tools that ultimately become its doom. This could be nuclear annihilation, a genetically engineered plague, runaway climate change, or perhaps a technology we haven't even dreamed of yet, like a physics experiment that goes horribly wrong and unravels the local fabric of spacetime. In this view, the eerie silence of the cosmos is not a sign of our uniqueness, but a galactic graveyard. The stars are silent because every civilization that reaches our stage is already dead, having succumbed to its own technological hubris. We are not listening for neighbors, we are listening for ghosts, and our own failure to find any may be the most ominous warning we will ever receive. Another deeply unsettling answer to the Fermi paradox is the dark forest theory, a concept popularized by the science fiction writer Liu Cixin. This solution posits that the universe is not a quiet wilderness but a dark forest teeming with life. Every civilization is a hunter, armed and paranoid, hiding in the trees. They remain utterly silent because to make a sound, to reveal your location, is to invite immediate and total annihilation. The logic is brutally simple. Any other civilization you encounter is an existential threat. You cannot know its intentions for certain, and the sheer scale of technological advancement means a less advanced species could potentially catch up and surpass you in a cosmic blink of an eye. The only safe assumption is that every other civilization will see you as a threat to be eliminated before you eliminate them. The safest, indeed the only, strategy for survival is to stay hidden, to listen intently, and to immediately obliterate any source of noise you detect. In this terrifying cosmic sociology, broadcasters like us, eagerly sending out messages and maps pointing to Earth, are not explorers seeking pen pals. We are children who have wandered into the middle of that dark forest, lighting a bonfire and screaming at the top of our lungs to see if anyone is there. We assume that any answer would be friendly or at least curious. The dark forest theory suggests the answer would be a precise and unstoppable relativistic kill vehicle, traveling at a significant fraction of light speed, launched to sterilize our planet before we ever become a real threat. The silence, then, is not a sign of absence. It is the sound of every other civilization holding its breath, afraid to make a sound, while they scan the frequencies for the foolish, the naive, and the soon-to-be extinct. But if the dark forest presents a universe of silent, paranoid predators, Our next terror reveals a reality where the predators are the galaxies themselves, engaged in a never-ending cycle of violent consumption on a scale that dwarfs all human conception of war. This is galactic cannibalism, a process not of delicate merging but of brutal gravitational dismemberment, and it is happening right in our own cosmic backyard. We often picture galaxies as isolated island universes drifting serenely through the void. The truth is far more savage. The cosmos operates under a simple, brutal law: the big eat the small. Our Milky Way is not a peaceful spiral. It is a predator, a shark in the dark waters of space, and it is already in the process of devouring its latest meal. That meal is the Sagittarius dwarf spheroidal galaxy. Discovered only in 1994, this tiny companion galaxy is currently in its death throes, caught in an orbital dance that will ultimately be its end. It's not on a collision course, it's on a disintegration course. Over countless passes, the Milky Way's immense gravity has been stretching the dwarf galaxy into cosmic taffy. With each close orbit, our galaxy strips away stars, gas, and dark matter from the dwarf, pulling long, shimmering streams of stars out into space. These stellar streams, great arcs of orphaned suns, now wrap around the Milky Way like the ribbons of a maypole, marking the grave of a galaxy that is being eaten alive. Telescopes can now map these faint rivers of light, the literal smear of stars across the sky that are all that remain of its original structure. It is a ghost, a galactic echo being digested by a larger beast. This isn't a rare event, it's the standard mechanism of galactic growth. The majestic spiral we see today was built over billions of years by consuming dozens of smaller galaxies. We are the product of cosmic carnage, and this cycle of consumption points toward a future event so colossal it will redefine our place in the universe. Our galaxy is on a direct collision course with the only other major galaxy in our local group, Andromeda. Right now, Andromeda is a faint, fuzzy patch of light in our night sky, a seemingly tranquil neighbor. But it is hurtling toward us at an unimaginable 250,000 miles per hour. In approximately 4.5 billion years, we will meet. The word collision is misleading. It won't be an explosive crash of stars because the vast distances between stars within each galaxy are so immense that direct stellar impacts are extraordinarily unlikely. Instead, it will be a slow-motion gravitational dance of unbelievable violence. The two galaxies will first pass through each other, their gravitational fields acting like immense nets, throwing stars into chaotic new orbits. The serene spiral arms of both the Milky Way and Andromeda will be utterly shredded and distorted beyond recognition. As they swing past each other, their momentum will carry them apart, but gravity will pull them back together. They will fall back into each other again and again over the course of hundreds of millions of years in a cosmic waltz of mutual destruction. During this chaotic merger, the night sky from Earth would be transformed into a spectacle of both terrifying beauty and utter chaos. The serene band of the Milky Way would be gone, replaced by a dazzling, chaotic smear of countless new stars, the incoming stars of Andromeda. Brilliant new star-forming regions would ignite as clouds of gas collide, lighting up the sky with blue-white nurseries of new suns. The core of the Andromeda galaxy would grow from a faint smudge into a brilliant, glowing hub dominating the heavens. It would be the most stunning light show in the history of our planet, visible even during the day. But this beauty comes with profound peril. While stars themselves are unlikely to collide, the solar system will not be spared. The gravitational turbulence has a very real chance of flinging our sun, and Earth with it, out of the newly merging galaxy entirely, sentencing us to the same lonely exile as a hypervelocity star cast into the intergalactic void. Alternatively, we could be thrown on a wild new orbit toward the crowded, dangerous central regions of the new galaxy. The gentle, stable environment that allowed life to flourish on Earth would be irrevocably shattered. The final product of this billion-year-long merger will be an entirely new galaxy, a giant, elliptical blob of stars that astronomers have nicknamed Milkdromda. It will be a featureless, star-filled sphere, a quiet retirement home for the survivors of a cosmic riot, its history of violent conquest hidden behind a serene, uniform glow. This isn't a distant possibility, it is an unavoidable certainty written into the motion of the stars themselves, a reminder that even the galaxies we call home are transient structures in an eternal cycle of creation and destruction. But if galactic cannibalism represents a slow, gravitational consumption, there exists a far more immediate and violent form of cosmic annihilation, one that doesn't just eat a galaxy but actively sterilizes it. This brings us to one of the most powerful and destructive forces in the entire universe, an engine of pure energy so fierce it can outshine 1,000 galaxies combined. We are talking about quasars and specifically the unimaginably powerful beams of death they can fire across intergalactic space. The term quasar stands for quasi-stellar radio source, a name born from their initial mystery. When first discovered, they appeared as star-like points of light, yet they emitted colossal amounts of energy, especially in radio waves. We now know they are anything but stars. A quasar is the incredibly bright, active core of a distant galaxy, and its power source is the most terrifying object we've encountered, a supermassive black hole. But not just any black hole. This is a black hole that is feasting, a cosmic predator in the middle of a veritable banquet. As vast amounts of gas, dust, and even entire stars spiral into the black hole's accretion disk, the material is torn apart by immense gravitational and frictional forces, heating up to millions of degrees before it plunges across the event horizon. This process converts matter into energy with an efficiency far beyond nuclear fusion, lighting up the galactic core with a brilliance that drowns out the light of every star in its host galaxy. The true terror, however, isn't just the light show. It's what happens along the black hole's axis of rotation. Amidst this chaotic feast, some of the infalling material, superheated and magnetized, is not swallowed. Instead, it is focused and accelerated by the black hole's powerful magnetic fields and shot out from its poles at nearly the speed of light. These are the quasar jets, unimaginably narrow and focused beams of high-energy radiation and particles stretching for hundreds of thousands, even millions, of light-years into intergalactic space. They are the universe's ultimate blowtorches, and they operate on a scale that defies human comprehension. The energy contained in a single one of these jets is beyond calculation, capable of punching through the gas between galaxies and delivering a devastating payload across cosmic distances. To be in the path of such a beam is a scenario of ultimate cosmic doom. It would be an extinction event that makes a nearby supernova look like a firecracker. There would be no warning flash, no slow build-up. If a quasar jet were pointed at our Milky Way, the first sign would be a torrent of gamma rays and high-energy particles slamming into our atmosphere. This would not be a brief flash like a gamma ray burst. It could be a continuous, relentless barrage lasting for thousands of years. The effect would be a slow, systematic sterilization of the entire galaxy. The jet's radiation would strip away planetary atmospheres, boil away oceans, and irradiate the surface of every world in its path. It would effectively scour the galaxy of any complex life, leaving behind a graveyard of dead, barren rocks circling dying stars. The jet itself would be visible as a brilliant, unwavering lance of light in the sky, a constant, terrifying reminder of an inevitable and inescapable end. The most chilling aspect of quasars is that they are not relics of a bygone era. They were more common in the early universe when galaxies were gas-rich and black holes had plenty to feed on. But they still exist today. The galaxy Markarian 231, for example, harbors a quasar powered by a binary supermassive black hole, and its jet stretches an astounding 1 million light-years into space. This serves as a stark reminder that the universe retains the capacity for such violent outbursts. While our galactic core is currently quiet, a dormant supermassive black hole sleeping at its heart, it too could be awakened. A major galactic merger or a large influx of gas could theoretically restart the engine, turning the center of our galaxy into a beacon of death once more, its beams sweeping across the cosmos like a searchlight from hell, a testament to the fact that even the most serene corners of the universe are never truly safe from the terrifying forces that built it. But this very act of reaching for the stars, of launching satellites and probes to explore the cosmos, has created a new and uniquely human kind of terror now circling our planet. It's a danger we built with our own hands, a self-made prison that could one day slam shut, trapping us on Earth forever. This is the Kessler syndrome, a catastrophic chain reaction of destruction waiting to happen in the orbital lanes above our heads, and it represents a potential end to the space age before it has even truly begun. Right now, Earth is enveloped in a swirling cloud of our own making. This isn't a poetic description, it's a literal, lethal fact. The space around our planet is cluttered with hundreds of thousands of pieces of debris, each one a bullet traveling at 17,500 miles per hour. This includes everything from defunct satellites and spent rocket boosters to a lost glove, a stray wrench, and millions of tiny fragments from explosions and collisions. At these orbital velocities, even a fleck of paint can chip a window on the International Space Station, and a metal screw carries the kinetic energy of a bowling ball fired from a cannon. This is the orbital junkyard we have created over decades, a testament to our ambition with a potentially devastating flaw. The Kessler syndrome, proposed by NASA scientist Donald Kessler in 1978, is the nightmare scenario that turns this junkyard into an inescapable trap. It begins with a single, catastrophic collision. Imagine two objects, perhaps an old, derelict satellite and a discarded rocket body crashing into each other. The impact doesn't just create two pieces of debris, it creates hundreds, even thousands of new fragments, each now a new and independent high-speed projectile. These new pieces fly off on their own chaotic orbits, significantly increasing the density of objects in that particular orbital shell. This dramatically raises the statistical probability of another collision. That second collision creates even more fragments, which leads to more collisions in a cascading, exponential chain reaction of destruction. Like a game of bumper cars where every crash spawns 10 new cars, the space around Earth would rapidly become a maelstrom of shrapnel. The end result of this cascade would be the formation of a dense belt of debris, a shell of whirling metal encasing the entire planet. Any object attempting to pass through this shell, a crewed spacecraft, a satellite, even a mission to the Moon or Mars, would be riddled with impacts likely destroyed. The launch windows for escaping Earth would effectively close. We would be sealed beneath a ceiling of our own garbage, our access to space completely cut off for generations, perhaps centuries. The satellites that modern life depends on for GPS, weather forecasting, global communications, and financial transactions would be gradually pulverized and could not be replaced. We wouldn't just be trapped, we would be thrust into a technological dark age, watching our global infrastructure fail piece by piece as our eyes in the sky are blinded one after another. This is not a distant, theoretical threat. We have already witnessed the first ominous cracks of this cascade. In 2009, a defunct Russian Cosmos satellite collided with an operational American Iridium communications satellite over Siberia. The collision, occurring at a combined speed of over 26,000 miles per hour, utterly destroyed both spacecraft and created over 2,000 large, trackable pieces of debris, plus hundreds of thousands of smaller, untrackable fragments. This cloud of shrapnel is still up there, a permanent addition to the orbital hazard. Even more chilling was China's anti-satellite test in 2007, where they deliberately destroyed one of their own weather satellites with a missile, creating the largest field of space debris in history at that time, with over 3,000 trackable objects that continue to threaten other satellites. These events were stark warnings, proof that the trigger for the Kessler syndrome is not only possible but has already been pulled twice. The true terror of this scenario is its permanence and our current powerlessness to stop it. In the vacuum of space, there is no air resistance to slow these objects down. Without active intervention, debris in low Earth orbit can remain a threat for decades. In higher orbits, like the geostationary belt where communication and weather satellites live, the debris can remain for centuries or even millennia. We are only now, belatedly, beginning to research technologies to address the problem, concepts like harpoons, nets, magnetic tugs, and lasers to nudge debris into destructive re-entry paths. But these are fledgling efforts. The cleanup technology needed to make a significant dent in the problem does not yet exist on an operational scale. For now, we mainly just track the largest pieces and maneuver active satellites out of the way, a cosmic game of dodgeball with increasingly high stakes. We stand at a precarious moment in history, on the verge of a new era of space exploration with plans for vast satellite constellations, lunar bases, and missions to Mars. Yet, we are simultaneously laying the groundwork for our own imprisonment. The Kessler syndrome is a silent, patient specter, a problem we created through carelessness and short-term thinking. It is a testament to the fact that the greatest horrors in space may not always be the ancient, alien forces lurking in the dark, but the very practical and immediate consequences of our own actions, a cascading disaster waiting to be set in motion by a single, unfortunate click of the cosmic billiard balls. But for all the silent, patient dangers we have created for ourselves, the universe is still more than capable of producing cataclysms of truly biblical proportions, events that don't just threaten a planet or a civilization, but that forge the very elements of life itself in a crucible of unimaginable violence. To witness such an event would be to stare into the heart of creation and see a face of pure, undiluted power. We are speaking of neutron star mergers, a cosmic collision so immensely powerful it literally shakes the fabric of the universe and scatters the seeds of future worlds across the void. The story begins with the corpses of two massive stars. Each was once a giant that lived fast and died young, ending its life in a supernova explosion that left behind not a black hole, but something almost as strange, a neutron star. Imagine the mass of our entire sun, compressed by gravity into a perfect sphere barely the size of a city. A single sugar cube-sized piece of this material would weigh as much as a mountain, its density so extreme that atoms themselves have been crushed out of existence, leaving behind a sea of pure neutrons. These stellar ghosts often exist in binary pairs, trapped in a gravitational embrace, orbiting each other in a dance that can last for eons. But it is a dance with an inevitable, tragic conclusion. With every orbit, they lose a tiny amount of energy, emitting it as ripples in space-time known as gravitational waves. This causes their orbits to slowly decay, drawing them inexorably closer together in a spiral that can last for millions of years, accelerating all the while until it culminates in a final, furious embrace. When they finally collide, the release of energy is beyond human comprehension. The two city-sized objects, each with a gravitational field billions of times stronger than Earth's, slam together at a significant fraction of the speed of light. The impact is so violent that it creates a tremor in the cosmos, sending powerful gravitational waves ringing out across the universe at the speed of light, a literal ripple in the fabric of reality itself. For a brief, spectacular moment, the collision creates the densest environment in the present-day universe, even surpassing the interior of a black hole. It is in this temporary, absurdly dense maelstrom that true cosmic alchemy occurs. In a process known as rapid neutron capture, or the R process, atomic nuclei are bombarded by a flood of free neutrons, allowing them to build up into the heaviest elements in the periodic table in a matter of seconds. It is here, in the heart of this dying inferno, that vast clouds of gold, platinum, uranium, and other precious heavy elements are forged and then blasted out into space at incredible speeds. The gold in your wedding ring, the platinum in a catalytic converter, were almost certainly born in the spectacular death throes of two colliding neutron stars billions of years ago. Yet this creative act is accompanied by a wave of pure destruction. The merger often results in a short-range gamma-ray burst, a focused beam of high-energy radiation that, for a few seconds, can outshine every star in the universe combined. If this beam were pointed directly at a nearby planet, the effect would be apocalyptic. The initial flash of gamma rays and X-rays would sterilize the side of the planet facing the event, obliterating its atmosphere and boiling its oceans in an instant. But even if a world is fortunate enough to be outside the direct kill zone, the aftermath holds another danger. The radioactive debris ejected from the merger spreads out in all directions, and any planetary system caught in this expanding cloud would be subjected to a rain of radioactive material for thousands of years. This could trigger mass extinctions and genetic mutations on a global scale, a lingering poison from a cosmic event light years away. The incredible power of these events was brought into stunning focus in August 2017. Observatories around the world detected gravitational waves from a merger event designated GW170817. For the first time, astronomers could pinpoint the location of the collision and train every available telescope on it. They witnessed the predicted kilonova, a transient explosion 1,000 times brighter than a typical nova, glowing with the unmistakable signature of newly created heavy elements. This single observation confirmed decades of theory, directly linking neutron star mergers to the creation of the universe's heaviest elements and proving that these colossal events are the universe's primary foundries for gold and platinum. It was a moment of profound discovery, revealing a process of both breathtaking creation and terrifying power. A reminder that the very materials that drive our economies and adorn our bodies were born in one of the most violent events since the Big Bang. And just as we look for evidence of our own existence in the echoes of ancient cosmic collisions, we have also spent decades actively listening, straining our electronic ears for any whisper in the silence that might suggest we are not alone. This search has yielded countless anomalies and false alarms, but one signal stands apart from all the rest, a singular event so perfect and so unexplained that it has become the ghost story of modern astronomy. It is known as the WOW signal, and it represents a 72-second mystery that has haunted the scientific community and the human imagination for nearly half a century. The story begins on a hot August evening in 1977 at Ohio State University's Big Ear radio telescope. This was part of the search for extracellular intelligence, or SETI, a project that methodically scanned the skies, tuning its receivers to the cosmic dial in the hopes of finding a signal that stood out from the natural radio hiss of the universe. The frequency it was listening to, around 1420 MHz, is a special one. It's a quiet band known as the water hole, where hydrogen and hydroxyl molecules emit and absorb energy, and it's a frequency many scientists believe would be a logical channel for any civilization trying to announce its presence. For nights on end, the telescope would slowly sweep the sky, its printouts recording little more than undulating lines of background static. But on August 15th, something extraordinary happened. As the telescope's gaze passed near the constellation Sagittarius, the needle jumped. The signal was strong, incredibly strong, 30 times louder than the ambient noise of deep space. It was a narrowband signal, meaning it was focused on one specific frequency, just the kind of signature you would expect from an intentional transmitter, as natural cosmic objects tend to broadcast over a wide range of frequencies. Most critically, it exhibited the telltale rise and fall in intensity that astronomers call the Gaussian curve. This is the exact pattern a signal from a fixed point in space should make as it moves into the narrow focus of a rotating radio telescope's field of view, peaks as it points directly at the source, and then fades away as the telescope moves on. It was perfect. It was exactly what everyone had been hoping to find, and it lasted for exactly 72 seconds, the full window that the big ear could observe that particular point in the sky. The discovery was made a few days later by a volunteer astronomer named Jerry Amon, who was reviewing the computer printouts. As his eyes scanned the alphanumeric string representing the signal's intensity, 6EQJ5, he was so stunned by its clarity and strength that he circled the sequence in red pen and simply wrote, "Wow." In the margin, that spontaneous expression of amazement gave the signal its now famous name. The immediate assumption was that this was it. This was the moment contact had been made. The search began to find it again, to confirm the discovery that would change humanity forever. The big ear listened to that same spot again and again. Other, more powerful telescopes were trained on the coordinates. The entire region was scoured for any repeat transmission, any hint of a follow-up, any clue at all. But there was nothing. The signal never returned, not that night, not the next year, and not in the decades since. Every attempt to detect it again has met with total, utter silence. It was a single, brilliant shout in the cosmic dark, followed by an eternity of silence. This singular, unexplained event has fueled endless speculation and debate. The most chilling possibility, of course, is that the WOW signal was exactly what it appeared to be, a genuine transmission from an extraterrestrial intelligence. Perhaps it was a targeted beacon, a focused message aimed precisely at our solar system that simply happened to arrive at the exact right moment for the big ear to hear it. We heard our name called, but by the time we turned around to answer, the caller was gone. Or maybe it was not a deliberate message, but a massive, omnidirectional leakage from an alien civilization's own communications or power generation. A brief, colossal burst of energy that washed over Earth like a wave and then receded, never to be repeated. The alternative explanations, while more mundane, are almost as puzzling. Some have suggested it could have been a signal reflected off a piece of space debris, like a discarded satellite booster, but no known object was in that position at that time. Others proposed it was a covert military transmission, though the frequency and the unique signature make this seem unlikely. The cometary hypothesis, which suggested the signal came from a passing comet emitting hydrogen, was later definitively ruled out as the comets in question were not in that region of the sky. With each terrestrial explanation debunked, the signal's mystery only deepens, its alien origins seeming more and more plausible. The profound and haunting implication of the WOW signal is its fleeting nature. It suggests a universe where contact might not be a continuous conversation, but a series of missed connections. Civilizations could be broadcasting for mere centuries, a blink of an eye on the cosmic scale, before they succumb to their own great filter and fall silent forever. Their signals would travel outward at the speed of light, not as a continuous ring, but as a single, expanding bubble in the ocean of space. Earth could be inside that bubble for just a moment, receiving a ghostly broadcast from a civilization that died out millennia ago. The WOW signal could be such a broadcast, a final, dying whisper that reached us, was heard by a single telescope for 72 seconds, and then vanished into the past. We would be left with the ultimate cosmic message in a bottle, a testament that we are not alone, but a message whose sender is long dead and whose meaning we will never decipher. It is the tantalizing possibility of contact, followed by the crushing, eternal silence of a universe that gives us just one brief, glorious hint before shutting the door forever. But as we listen for ghostly transmissions from the void, we are forced to confront a terror that is not speculative, not a distant possibility, but a cosmic certainty written into the very life cycle of our own star. This is a cataclysm with a countdown clock, an apocalypse that requires no rogue black hole or gamma-ray burst, because the engine of our own destruction is the gentle, life-giving sun that rises each morning. Billions of years from now, our sun will cease to be the source of all life and will instead become the agent of its absolute and total erasure. This is the fate of a red giant, and it is the inescapable future of our solar system. The process begins quietly, deep within the sun's core. For billions of years, our star has been performing a stable, magnificent balancing act, fusing hydrogen into helium and releasing the energy that has nurtured life on Earth. But this fuel is not infinite. Slowly, inevitably, the hydrogen in the core will be exhausted. Without the outward pressure from fusion to counteract the immense force of gravity, the sun's core will begin to contract. This contraction, however, will have a terrifyingly paradoxical effect. As the core shrinks, it grows hotter and denser. This newfound heat ignites a shell of hydrogen fusion around the inert core, causing the sun's outer layers to balloon outward at a spectacular rate. Our sun will begin to swell, transforming from the familiar yellow dwarf into a monstrous red giant. The first act of this tragedy will be a slow-motion fever for Earth. As the sun expands, its luminosity will steadily increase. Millions of years before it physically touches our planet, the rising heat will begin to cook the biosphere. The delicate balance of our atmosphere will be shattered. The oceans will start to simmer, their waters heating until they enter a runaway greenhouse effect. The water vapor released will trap even more heat, accelerating the process until the skies are choked with steam and the global temperature soars to hundreds of degrees. The oceans will not simply evaporate peacefully, they will boil. The very seas that gave rise to life will begin to bubble and churn under a sun that appears larger and more malevolent in the sky with every passing century. The continents will bake into global deserts, their rocks glowing with heat, and the last remnants of any life will be scoured from the planet's surface. Every mountain, every city, every trace of human civilization will be sterilized and bleached by the intense, unforgiving heat long before the star itself arrives. Then will come the final, physical embrace. The sun will continue its expansion, its outer layers reaching out across the inner solar system. It will consume Mercury, then Venus, each planet vanishing without a trace into the tenuous but incredibly hot outer atmosphere of the star. Finally, the sun's limb will touch Earth. Our planet will not be swallowed whole in an instant. Instead, it will begin an agonizingly slow death spiral. As it plows through the diffuse outer layers of the star, it will experience intense atmospheric drag, slowing its orbital velocity. With each loop, Earth will spiral closer to the sun's core, its orbit decaying over thousands of years. The sky will no longer be blue, but a hellish, uniform red glow in every direction, with the sun's core a blinding, unbearable furnace at the center of it all. The surface of the planet will melt, its very rocks and metals turning to lava, until finally, the last fragments of what was once our world are vaporized and assimilated into the body of the star. Every atom that made up our home, every fossil, every monument, every memory, all of it will be returned to the stellar forge from which it came, annihilated beyond any possible recovery. The profound horror of this scenario lies not in its violence, but in its absolute inevitability. This is not a potential disaster. It is a guaranteed outcome dictated by the fundamental laws of stellar physics. Our sun has no choice in this transformation. It is a predetermined path that every star of its mass must follow. The universe will continue on, utterly indifferent to the complete and total erasure of every achievement, every struggle, and every moment of beauty that ever occurred on our tiny, pale blue dot. It is the ultimate reminder of our transience, a scheduled appointment with oblivion that cannot be cancelled or postponed. This future renders all of human history, in the grandest cosmic scale, a fleeting and temporary phenomenon, a brief, bright spark that will, in the end, be consumed by the very fire that gave it life. But our sun's eventual demise, while certain, is a fate scheduled for the far future. The terror we face now is far more immediate and hails from the deepest, darkest frontier of our own solar system, a place so distant and mysterious it remains largely theoretical. This is the Oort cloud, a spherical shell of icy debris that forms the true outer boundary of our sun's gravitational influence, and it holds a frozen army of potential extinction events just waiting for the right gravitational push to send them screaming toward us. Imagine the solar system not as a flat disk ending with Pluto, but as a nested set of structures. Inside the orbit of Neptune, you have the familiar planets. Beyond that, you have the Kuiper belt, a donut-shaped region of icy bodies that includes Pluto. But the Kuiper belt is just the inner porch. The true backyard of our solar system is the Oort cloud, a vast, theoretical shell of icy planetesimals that begins roughly 2,000 astronomical units from the Sun and stretches outward to a mind-numbing 100,000 astronomical units. To put that inconceivable distance in perspective, 1 astronomical unit is the distance from the Earth to the Sun. The inner edge of the Oort cloud is 2,000 times farther away than we are from the Sun, and its outer edge is a quarter of the way to the nearest star. This isn't just deep space, this is the absolute hinterland of our solar system, a place where the Sun is just a particularly bright star, offering little light and even less warmth. The objects that make up this cloud are the leftover building blocks of the solar system, pristine balls of ice, rock, and organic compounds that were flung out into these distant orbits by the gravitational interactions of the giant planets billions of years ago. They are time capsules from the dawn of creation, and there are trillions of them. Most are no larger than a few kilometers across, but some are the size of mountains, and a few could be the size of small planets. They drift in a deep freeze so profound that a single orbit around the Sun can take millions of years. This cloud is the source of the long-period comets, those spectacular, unpredictable visitors that suddenly appear from every direction in the sky, unlike the short-period comets from the Kuiper belt that follow more predictable paths. The true terror of the Oort cloud lies in its perfect stability and its perfect instability. For millions of years, these icy worlds can drift in their silent, timeless orbits, utterly harmless. But their orbits are so vast and so loosely bound by the Sun's weak gravity out there that the slightest nudge is all it takes to change everything. This nudge doesn't require a direct impact. The mere gravitational influence of a passing star is enough. As our solar system bobs up and down through the plane of the Milky Way galaxy, other stars inevitably pass relatively close by. Right now, we are awaiting the close approach of a star called Gliese 710, which in about 1.3 million years will pass within just 13,000 astronomical units of the Sun, well within the outer Oort cloud. When that happens, its gravity will act like a shepherd's crook tugging on countless of these icy bodies. For most, the tug will be slight, altering their orbit but keeping them in the cloud. For some, it will send them drifting harmlessly outward into interstellar space. But for an unfortunate few, the perturbation will be just right to send them falling inward toward the heart of the solar system and on a potential collision course with Earth. The journey of one of these perturbed comets is a lesson in delayed horror. Once knocked from its stable orbit, it begins a fall toward the Sun that can last for hundreds of thousands of years. For almost the entirety of that journey, it is a dark, inert snowball, invisible to our telescopes. There is no glowing coma, no beautiful tail. Those only form when a comet gets close enough to the Sun for its ices to begin vaporizing. By the time it becomes visible to us, it may already be inside the orbit of Jupiter, giving us only a few months or years of warning. And a long-period comet is far more dangerous than a typical asteroid. It approaches the inner solar system from any angle, not just the plane of the ecliptic where the planets orbit, making its path harder to predict. It also travels much faster, having fallen from a much greater height in the Sun's gravitational well, meaning the impact energy would be catastrophic. A city-sized comet from the Oort cloud striking Earth would not just be an impact, it would be a global firestorm followed by a centuries-long winter, an event that would reset the course of evolution. The irony is profound. The same passing star that might grant a distant astronomer a breathtakingly beautiful comet to observe could also, simultaneously, be nudging another unseen icy planet killer onto a path that ends all life on our world. The Oort cloud is a frozen reservoir of doom, a reminder that the greatest threats to our existence may not come from within our solar system or even from outside our galaxy, but from the silent, dark, and unimaginably vast borderlands of our own sun's domain, where a gentle push from a stranger passing in the night can unleash an apocalypse set in motion millions of years in the past. But for all the immense power locked within a neutron star's gravity, there is a variant of these stellar corpses that possesses a weapon far more bizarre and instantly destructive than its mass alone. Imagine the strength of a typical neutron star's magnetic field, already billions of times stronger than anything we can generate on Earth. Now amplify that by 1,000-fold. You have just envisioned a magnetar, and its magnetic field is so impossibly powerful that it fundamentally warps the nature of reality itself in its immediate vicinity. This is not merely a strong magnet, it is a cosmic force of pure electromagnetic terror. A magnetar is a neutron star born in the most extreme conditions, its unimaginable magnetic field likely generated by a perfect storm of factors during its progenitor star's collapse, a rapidly spinning core and a convection process that acts like a dynamo, twisting the magnetic field lines into a state of unimaginable tension. The numbers defy comprehension. The Earth's magnetic field measures about 1 Gauss. A strong refrigerator magnet is about 100 Gauss. A magnetar's field measures 1 quadrillion Gauss. At a distance of 100,000 miles from a magnetar closer than our moon is to us, this magnetic field would be instantly, fatally lethal. It would not just erase the magnetic strip on your credit cards, it would erase you. The field is so powerful it would polarize the atoms that make up your body, stretching them into thin, needle-like rods, disrupting the very chemical bonds that hold you together. It is a force that rips matter apart at a subatomic level. Fortunately, there are no magnetars that close to us. The true, global-scale terror lies not in their proximity but in their instability. These monstrous magnetic fields are under unimaginable stress, locked into the solid, city-sized crust of the neutron star. This crust is under such immense strain that it occasionally cracks, much like the tectonic plates on Earth. But on a magnetar, these events are not earthquakes, they are starquakes, and when this ultra-dense crust fractures, it releases more energy in a fraction of a second than our Sun emits in 100,000 years. This energy doesn't just burst out as light, it is channeled by that incredible magnetic field, unleashing a focused eruption of X-rays and gamma rays in a colossal flare. We have witnessed this happen. In December 2004, a magnetar named SGR 180620, located 50,000 light-years away in the constellation Sagittarius, had a starquake. For 0.2 of a second, it released more energy than our Sun has emitted in the last 250,000 years. The blast of radiation was so powerful that it actually compressed Earth's ionosphere, briefly altering the propagation of long-range radio signals. It was the most luminous event from outside our solar system ever recorded by human instruments, and it came from an object halfway across the galaxy. Now consider the implications of a similar event from a magnetar just a few hundred light-years away, a distance that is practically our own stellar neighborhood. The effect would not be a wave of heat or a destructive impact. It would be an electromagnetic apocalypse. The initial flash of high-energy radiation would be bad enough, ionizing our atmosphere and triggering chemical reactions that would destroy the ozone layer, similar to a nearby gamma-ray burst but on a potentially more focused scale. But the real, insidious damage would come from the secondary effect. The blast would create a wave of charged particles that would wash over the entire planet, inducing massive electrical currents in anything long and metallic. Our entire planet would experience the mother of all electromagnetic pulses. The global electrical grid, the backbone of modern civilization, would be hit first. Massive transformers at power substations would overload and melt down, exploding in a shower of sparks and oil. The lights would go out not in a city or a country, but on a continent-wide scale, and they would not come back on for years, as manufacturing the specialized replacements for these multi-ton components is a slow, global process. Every satellite in orbit would be fried, their delicate electronics fused into useless silicon. GPS, global communications, and weather monitoring would vanish instantly. But the damage would drill down much deeper. The complex integrated circuits in every modern device, in hospitals, in water treatment plants, in banking systems, and in the devices in your pocket, would be irreparably scorched. The stored data on hard drives and servers worldwide could be wiped clean as the magnetic surge scrambles their delicate patterns of ones and zeros. In the span of a few seconds, we will be thrust back into a pre-industrial age, but with a post-industrial population of billions utterly dependent on the very technology that had just been obliterated. There would be no internet, no telephones, no power, no navigation, and no way to coordinate a global response. The event would be silent and invisible, but its aftermath would be a collapse of civilization fueled by a star that screamed 50,000 years ago. A magnetar does not need to be close to kill us. It simply needs to be close enough to send a silent, light-speed command that tells our own technology to destroy itself, proving that the universe holds dangers that can strike at the very heart of human progress without ever lifting a physical finger. Yet even the seemingly solid structure of matter itself, the very fabric of stars and planets and life, may not be safe from the universe's ultimate fate. We've witnessed the terrifying power of a magnetar's magnetic field, a force that can tear reality apart on a subatomic level. But what if the entire cosmos held a similar, latent power, a force not of magnetism but of expansion so relentless that it could eventually unravel everything down to the last atom? This is not the heat death of the universe, a slow freezing into darkness. This is a far more violent and dramatic finale known as the Big Rip, an apocalypse of pure, unstoppable acceleration that would shred the cosmos itself. The engine of this terrifying end is the very same mysterious force that astronomers discovered using distant supernova, dark energy. This enigmatic pressure is what's causing the expansion of the universe to accelerate, pushing galaxies apart at a faster and faster rate. For now, its effect is felt only on the grandest scales in the vast voids between galaxy clusters. But the Big Rip hypothesis presents a chilling question. What if dark energy isn't constant? What if it gets stronger over time? This particular hypothetical form of dark energy is known as phantom energy. If it exists, its repulsive force would not remain a gentle nudge, but would instead grow in strength, eventually overwhelming every single force that holds the universe together. The end would not come all at once, but in a carefully ordered sequence of destruction, a reverse of creation itself. The first structures to go would be the largest and most loosely bound. Billions of years before the final moment, the acceleration would become so fierce that it would overcome the gravitational glue holding galaxy clusters together. These vast archipelagos of stars would be flung apart, their constituent galaxies isolated in a rapidly expanding void. Next, the force would turn on the galaxies themselves. The gravitational pull of a supermassive black hole at the center of a galaxy like our Milky Way is immense, but it would be no match for the escalating push of phantom energy. Individual galaxies would be torn apart, their stars sent scattering into the growing darkness like sparks from a dying fire. As the end draws nearer, the phantom energy's influence would scale down to our own solar system. The Sun's gravitational hold on Earth and the other planets would be overcome. Our planet would be ripped from its orbit, cast adrift into an incomprehensibly empty and rapidly widening space. But the horror is only beginning. The very planets and stars themselves would be next. The gravitational force that crushes a star's core, that fuses atoms and creates light, would be the next bond to break. Stars and planets would simply fly apart, their constituent matter no longer held together by gravity. There would be no more suns, only a diffuse cloud of interstellar gas and dust spreading infinitely apart. In the final moments, the phantom energy would perform its most diabolical act. It would target the forces that hold atoms together. The electromagnetic force that binds electrons to a nucleus and the strong nuclear force that glues protons and neutrons together would be vanquished. Every single atom in the universe would be systematically dismantled. Molecules, cells, people, planets, everything would be reduced to a thin, expanding mist of fundamental particles, each one unable to ever interact with another again as the space between them expands faster than the speed of light. The universe would end not with a whimper, but with a scream of ultimate dissolution, a transition from a complex, structured cosmos of beauty and wonder into a formless, empty, and eternal void where nothing can ever exist again. It is the most absolute and terrifying end conceivable, a total victory of expansion over structure, leaving behind a reality where the concept of where or when has no meaning at all. But if a magnetar's wrath is a sporadic, violent tantrum, there exists another type of stellar corpse that delivers its punishment with the unerring, mechanical precision of a cosmic executioner. These are pulsars, the lighthouses of the dead, and the worlds that orbit them exist in a special kind of hell, subjected to a relentless, sterilizing barrage that turns the very idea of a habitable planet into a grotesque parody. To understand the nightmare of a pulsar planet, you must first witness the brutal birth of its sun. A pulsar is a rapidly spinning neutron star, the dense remnant of a supernova explosion. But unlike a quiet, dormant neutron star, a pulsar is animated by an insane rotational velocity, spinning hundreds of times per second. This frantic spin is a consequence of the core collapse that created it, a principle of physics similar to an ice skater pulling their arms in to spin faster. As the star's core collapses from a sphere larger than Earth down to the size of a city, its rotation rate skyrockets, but the true signature of a pulsar is its beam. The neutron star's intense magnetic field, trillions of times stronger than Earth's, funnels particles accelerated to near light speed out from its magnetic poles. This creates two narrow, powerful beams of radiation, everything from radio waves to lethal gamma rays, that shoot out into space like the beams of a cosmic lighthouse. If the neutron star's rotation axis is misaligned with its magnetic axis, these beams sweep through the cosmos with each rotation. From a distance, if one of those beams periodically sweeps across Earth, we detect it as a precise, repeating pulse of energy, hence the name pulsar. The timing of these pulses is astonishingly regular, more accurate than any atomic clock humanity has ever built. But this mesmerizing clockwork rhythm is the heartbeat of a monster. Any planet orbiting close enough to be warmed by the pulsar's feeble residual heat would find itself directly in the line of fire of these sweeping beams of death. This isn't sunlight, it's a searchlight of pure radiation, turning the entire surface of the planet into a killing field with every single rotation. The discovery of the first planets ever found outside our solar system wasn't around a friendly, sun-like star, but around such a cosmic horror. In 1992, astronomers studying the pulsar PSRB 1257+12 detected slight, rhythmic variations in its impossibly precise clockwork pulses. The only explanation was the gravitational tug of at least 3 small planets orbiting this stellar corpse. These worlds were not born with the pulsar. They are likely the horrifying survivors of the apocalypse that created it, the shattered, rocky cores of planets that once orbited the star in its previous life, or perhaps bodies that coalesced from the fallback debris of the supernova explosion itself. They are the children of catastrophe, forever bound to their parents' corpse. The environment on such a world is beyond hostile. The surface would be continuously scoured by the pulsar's relentless stellar wind, a torrent of high-energy particles. But the true horror arrives with the beam itself. Imagine a world where several hundred times every second, a wave of ionizing radiation sweeps across the landscape. This is not a gentle wave of light, but a pulse of energy so intense it would instantly deliver a lethal dose of radiation to any known form of life. The entire planet would be flash sterilized over and over again with the monotonous regularity of a metronome. There is no night to provide respite, no atmosphere thick enough to provide a reliable shield. The very rock of the planet would be rendered radioactive and glassy under this constant assault. Any potential chemistry that could lead to life would be shattered and broken down as quickly as it could form. These are not worlds, they are tombs locked in a dance with a dead partner that refuses to stop firing. The existence of pulsar planets is a testament to the sheer resilience of matter, that planets can form and persist in the most unimaginably violent environments. But they also represent the ultimate dead end for life. They are a chilling counterpoint to the hopeful search for Earth-like worlds in the habitable zones of quiet stars. They prove that a planet can exist, but its sun can still be the instrument of its perpetual damnation, a beacon not of hope but of eternal, rhythmic death. But the unsettling idea of a pulsar's deadly rhythm presents a universe of inescapable, localized danger, a star that actively murders its own planets. This leads us to a horror of a completely different scale, a theory that doesn't just explain why we might find dead worlds, but why the entire cosmos seems so profoundly and unnervingly silent. We return to the haunting question of the Fermi paradox and to one of its most chilling possible answers. The universe is not empty, it is not a peaceful wilderness. It is a dark forest, and every civilization is a hidden hunter, armed and terrified, holding its breath in the shadows. This concept, known as the dark forest hypothesis, transforms the cosmos from a potential community into a deadly game of survival where the only rule is to stay silent. The logic is brutally simple, built on a few core axioms that are difficult to argue with. First, all civilizations will inherently seek to survive and acquire resources to ensure their continued existence, a drive we see in every form of life on our own planet. Second, the distances between stars are so vast that it is impossible to know another civilization's true intentions or capabilities. You cannot have a real-time conversation, a simple hello, and its reply could take centuries or millennia. This creates an insurmountable wall of uncertainty. And third, technology's potential for destruction grows exponentially with a civilization's advancement. A species just a few hundred years more advanced than us could possess weapons and capabilities that are utterly incomprehensible to us, perhaps even the power to dismantle stars or reshape reality itself. Given these facts, the dark forest theory argues that the only safe assumption any civilization can make is that any other civilization it detects is an existential threat. The potential downside of being wrong is absolute. If you assume they are peaceful and they are not, your entire species is erased from the cosmic record. Conversely, the potential upside of making contact is at best a gain of knowledge or an ally, but the risk-reward calculation is catastrophically unbalanced. The safe, rational choice for any species that wishes to survive is therefore to preemptively eliminate any other civilization it discovers before that civilization has the chance to do the same. It is a universe-wide prisoner's dilemma with the highest possible stakes, where the dominant strategy is not cooperation, but immediate and total betrayal. In this terrifying cosmic sociology, the silence we hear is not a sign of our loneliness or rarity. It is the sound of a universe holding its breath. Every other civilization is listening just like we are, but they are doing so with their fingers on the trigger. To broadcast your location is the ultimate act of foolishness. It is the equivalent of a child lost in a dark and predator-filled forest, lighting a match and screaming, "Is anyone there?" The response would not be a friendly callback. It would be a precisely aimed shot from the darkness, a relativistic kill vehicle, perhaps a simple rock accelerated to a significant fraction of light speed, launched to sterilize your planet before your radio signals have even finished announcing your presence to the rest of the galaxy. This theory paints our own efforts at SETI, the search for extraterrestrial intelligence, in a terrifying new light. Our attempts could be seen not as a hopeful search for brothers, but as a dangerous act of eavesdropping on a conversation everyone else is too smart to have. Even more frightening is the concept of messaging extraterrestrial intelligence, where we actively beam powerful, targeted messages at specific star systems. To proponents of the dark forest, this is not exploration. It is cosmic suicide, the equivalent of shouting our home address into the darkest alley in the universe. The dark forest resolves the Fermi paradox not with an answer of absence, but with an answer of presence. They are out there, but they are silent, paranoid, and dangerously armed. The great filter may not be behind us or ahead of us, but all around us, woven into the fabric of cosmic reality itself. It is the terrifying logic of a universe where the only way to ensure you see the next dawn is to ensure no one else knows you are there to cast a shadow. Yet even as we look for monsters in the depths of space, some of the most unnerving mysteries have been found much closer to home, hidden in the subtle, unexpected behavior of our own robotic explorers. For decades, two human-made objects hurtling into the void presented scientists with a small but persistent puzzle, a tiny deviation from the expected path that whispered of forces we might not fully understand. This is the story of the Pioneer anomaly, a haunting reminder that sometimes the most profound secrets are not announced with a bang, but with a barely perceptible whisper. In the early 1970s, humanity launched its first emissaries destined to leave our solar system. Pioneer 10 and Pioneer 11 were rugged, Pioneer-class probes sent on a grand tour of the outer planets before being cast outward on a permanent trajectory into interstellar space. For years, they dutifully phoned home, their signals a steady heartbeat from an ever-increasing distance. But as teams at NASA, a jet propulsion laboratory, meticulously tracked their progress, they noticed something peculiar. Both spacecraft were experiencing a tiny, unexpected, and constant deceleration. It was as if a faint, invisible hand was reaching out from the direction of the sun, ever so gently applying the brakes to their journey into the great unknown. This minuscule drag was equivalent to just 10 billionths of the gravity we feel on Earth's surface, a force so small it should have been negligible. Yet it was there, persistent and unaccounted for in all the complex equations of orbital mechanics. This tiny anomaly became a massive headache for physicists. For over 30 years, it defied conventional explanation. The deviation was so small it could have been dismissed as a trivial instrumentation error, but its persistence across two separate spacecraft traveling in different directions suggested it was a real physical effect. The implications were staggering. If our understanding of gravity was even slightly incorrect on this scale, it could mean our models of the entire cosmos were fundamentally flawed. The anomaly became a rallying point for those proposing new physics. Perhaps it was evidence of unseen, non-luminous matter, dark matter exerting a gravitational pull we hadn't anticipated. Maybe it was a sign that Einstein's theory of general relativity needed a slight modification at the extreme scales of the solar system. Some even ventured into more exotic territory, suggesting it was evidence of higher dimensions subtly influencing our own or a local manifestation of a universal force we had yet to discover. The mystery festered for decades, a tiny splinter in the finger of modern physics. Then, through a Herculean effort of scientific detective work, a team led by Slava Turishev dove into the problem. They didn't just look at new physics, they went back to the old data, recovering telemetry from vintage magnetic tapes and old formats that required ancient equipment to read. Their breakthrough was both brilliant and mundane. They realized the answer wasn't in the void of space, but in the spacecraft themselves. The Pioneer probes were powered by radioactive plutonium, which generated heat. That heat had to be radiated away to keep the instruments functioning. The team built an incredibly detailed thermal model of the probes and discovered that this heat was not radiating away perfectly symmetrically. More heat was being emitted from the back of the spacecraft, where the power systems were located, than from the front. This tiny imbalance created a recoil force, a photon rocket effect where the photons carrying the heat away also carried a tiny amount of momentum. This minute push was directed back toward the sun, perfectly mimicking a constant sunward deceleration. The mysterious force wasn't a new law of physics, it was the spacecraft's own warmth, finally accounted for with exquisite precision. While the thermal radiation explanation is now widely accepted, solving the primary mystery, the Pioneer anomaly leaves behind a profound and lingering unease. It serves as a powerful cautionary tale about the arrogance of certainty. For over 3 decades, our best and brightest were convinced a new physical phenomenon was at play, when the true culprit was a simple engineering effect we had overlooked. It highlights the immense challenge of deep space navigation, where an error in calculation smaller than a butterfly's breath can send a probe millions of miles off course over a long enough timeline. It whispers that our grasp on the laws of the universe, while strong, might still have tiny, hidden cracks. We corrected for this one, but what other subtle forces are we still missing? What other tiny anomalies in the data from distant probes are we currently attributing to noise that might one day be revealed as a fundamental flaw in our understanding? The terror of the Pioneer anomaly isn't that a ghost was pulling on our spacecraft. It's the terrifying possibility that for all our knowledge, we are still just learning to see in the dark, and the next anomaly we ignore could be the one that changes everything. But for all the immense and dramatic dangers we've explored, from colliding neutron stars to the silent logic of a dark forest, there exists a far more constant and insidious threat, one that never ceases and from which there is no true hiding. It is an invisible rain, a silent storm of atomic shrapnel that fills every cubic inch of our solar system, a remnant of the universe's most violent events that now poses a fundamental barrier to our dreams of reaching the stars. These are galactic cosmic rays, and they represent a pervasive, low-level horror that is with us every single second of every single day. Imagine the aftermath of a supernova explosion, the catastrophic death of a giant star. In its final moments, it doesn't just release light, it acts as a natural particle accelerator of almost unimaginable power. Its expanding shockwave rips through space, catching atomic nuclei, mostly protons and helium nuclei, but also heavier elements, and whipping them up to velocities approaching the speed of light. These particles become cosmic bullets, stripped of their electrons and charged with immense energy. They are ejected in all directions, and they do not travel alone. Similar processes around active galactic nuclei and quasars contribute to this hail of high-energy matter. This is not a localized event. It is a permanent, diffuse background radiation that permeates the entire galaxy, a faint echo of stellar screams that happened millions of years ago. Here on the surface of Earth, we are blissfully unaware of this perpetual bombardment. We are protected by a dual-layer defense system of remarkable efficiency. First, our planet's magnetic field acts as a giant shield, deflecting the charged particles toward the poles, where they interact with the atmosphere to create the beautiful auroras. The particles that do make it through then slam into our thick atmosphere, which acts as a protective barrier miles deep, ensuring that the radiation we experience at ground level is negligible. Our bodies have evolved under this blanket of security, our DNA largely shielded from this constant subatomic assault. But venture beyond this protective cocoon and you step directly into the storm. For astronauts on the International Space Station, the risk is already measurably higher. While the station still orbits within the protective bulge of Earth's magnetosphere, astronauts receive a dose of radiation equivalent to about one whole body CT scan per week. This increased exposure is a known occupational hazard, carefully monitored and factored into their career limits, but the true, terrifying implications of cosmic radiation become apparent when we contemplate leaving this protective magnetic bubble entirely. A journey to Mars, for instance, would involve spending 6 to 9 months in interplanetary space, completely exposed to the full brunt of the galactic cosmic ray background. There is no magnetic field in interplanetary space to deflect these particles, and a spacecraft's hull offers little more protection than a sheet of paper. The damage these particles inflict is not like a blast of heat or a wave of force. It is a silent cellular sabotage. When a high-energy cosmic ray nucleus moving at nearly light speed tears through a human body, it doesn't just leave a clean path. It acts like a microscopic cannonball, creating a trail of ionization, knocking electrons loose from atoms as it passes through tissue. But the most devastating effects come from the shrapnel it creates. When one of these primary particles collides with the nucleus of an atom inside an astronaut's body, it can shatter that nucleus, creating a secondary spray of even more particles that fan out, causing a cascade of damage through nearby cells. This is not a single point of injury. It's a microscopic shotgun blast ripping through the delicate machinery of life. The primary concern for long-duration spaceflight is the relentless accumulation of this damage to DNA. Cosmic radiation doesn't just break DNA strands, it breaks them in complex, hard-to-repair ways. Our cellular repair mechanisms, which evolved to handle simpler types of damage from sources like sunlight, can become overwhelmed by this complex damage, leading to mutations. These mutations significantly increase the lifetime risk of developing cancer, but the threat may be even more sinister and immediate. Studies on rodents exposed to radiation similar to what would be experienced on a Mars mission have shown alarming cognitive deficits. The high-energy particles appear to damage the delicate structures of the brain, particularly inflammation in neural networks, leading to issues with memory, learning, and decision-making. An astronaut on a long journey could potentially experience a slow, irreversible decline in their mental faculties, a terrifying prospect when their survival depends on sharp cognitive function millions of miles from any help. Shielding against this threat is a monumental engineering challenge. You cannot simply wrap a spacecraft in lead. The weight would make it impossible to launch. Furthermore, a thick shield made of heavy elements could actually make the problem worse by increasing the number of secondary particles created when cosmic rays collide with the shielding material itself. The most promising solutions are still largely theoretical, using active shielding that creates an artificial magnetic field around the spacecraft, or employing lightweight materials rich in hydrogen, like water or polyethylene, which are more effective at absorbing radiation without creating excessive secondary spray. But these technologies are in their infancy. For now, galactic cosmic rays represent the most stubborn and unavoidable physical barrier to humanity becoming a spacefaring species. They are the silent, invisible toll booth on the road to the stars, demanding a price in increased health risks that we do not yet know how to pay. A constant reminder that the universe is not just filled with spectacular explosions, but with a pervasive, quiet hostility that may ultimately keep us trapped in our own celestial backyard. But this very bombardment, this cosmic rain that threatens our future in space, is itself a product of the universe's most violent and creative acts, the life and death of stars. And within those stellar furnaces lies a coincidence so precise, so perfectly tuned, that it feels less like a law of physics and more like a lock on a door that, if the combination were off by even a single digit, would have left the universe forever dark and lifeless. This is the triple alpha process, and its terrifying perfection suggests that the existence of every one of us hangs by a thread of unimaginable cosmic fragility. To understand this razor's edge, we must journey into the heart of a dying star. When a star like our Sun exhausts its hydrogen fuel, its fate is a relatively quiet one, cooling into a white dwarf. But for stars more massive, the end is a far more dramatic and creative inferno. As the core runs out of hydrogen, it contracts under its own immense gravity, heating up until it reaches the staggering temperature of 100 million degrees Kelvin. At this point, it can begin to fuse the next element in line, helium. The process starts simply enough. 2 helium-4 nuclei, each with 2 protons and 2 neutrons, collide and fuse to form a beryllium-8 nucleus. And here we encounter the first seemingly insurmountable barrier to our existence. Beryllium-8 is wildly, spectacularly unstable. It has a half-life of only about 86 quintillionths of a second. It falls apart almost the instant it forms. In any reasonable universe, the story would end right here. The fusion process would hit a dead end. The core of the star would never progress beyond helium, and the creation of heavier elements like carbon, the very foundation of life, would be impossible. The universe would be filled with hydrogen, helium, and a useless, vanishingly tiny trace of unstable beryllium. There would be no planets, no chemistry complex enough for life, and certainly no one to wonder about it all. But our universe is not reasonable. It is, against all odds, precisely tuned. Just as the beryllium-8 is formed and is in the process of decaying, a miracle occurs. A third helium nucleus, moving at just the right speed, slams into the unstable beryllium-8 nucleus before it has a chance to fall apart. This 3-body collision, the triple alpha process, fuses them together to form a nucleus of carbon-12. This itself seems like a 1 in a quadrillion shot, a statistical impossibility, but it isn't just luck. The reason this reaction works at all, the reason it isn't impossibly slow and inefficient, is due to a breathtakingly precise property of the carbon-12 nucleus itself. It possesses what physicists call a resonant state. Think of it like pushing a child on a swing. If you push at just the right moment in the swing's arc, a small push adds a lot of energy very efficiently. Push at the wrong time and you work against the motion. The energy level produced by the collision of beryllium-8 and a helium nucleus precisely matches a natural, excited energy state within the carbon-12 nucleus. This resonance acts like a catcher's mitt, dramatically increasing the probability of the reaction and allowing carbon to be forged in abundance inside stars. The terror and the wonder of this is in the numbers. The energy of this resonant state is 656 million electron volts. If this value were just 4% higher, the reaction rate would be too slow and stars would produce negligible amounts of carbon. If it were just 4% lower, the process would be too efficient, and nearly all the carbon would quickly fuse into oxygen, leaving little behind. In either scenario, the universe becomes a desert devoid of the fundamental building block of life as we know it. This precise energy level is not predicted by any fundamental theory. It is a brute fact of our universe, a number that appears to be set at exactly the value needed to allow carbon-based life to eventually emerge. It feels like a fix, a cosmic parameter deliberately tuned to allow for our existence. This incredible fine-tuning, known as the anthropic principle, is a source of profound unease for physicists and philosophers alike. It presents us with a deeply unsettling set of possibilities. One is that we are the beneficiaries of a staggering, almost miraculous cosmic coincidence. We won a lottery with odds so astronomically against us that it defies rational belief. The other, even more mind-bending possibility is that our universe is just one of perhaps an infinite number of universes in a vast multiverse, each with its own randomly set physical constants and laws. In the overwhelming majority of these universes, the resonance level is wrong, and those worlds are barren, silent, and dead. We simply happen to exist in one of the vanishingly rare universes where the numbers worked out, and so we are here to be amazed by it. This doesn't provide comfort, it simply exchanges one miracle for another, suggesting a reality where life is not an intended outcome but a random fluctuation in a mostly dead and hostile multiverse. The triple alpha process is not just a nuclear reaction. It is the ultimate existential cliffhanger, revealing that the foundation of our very being rests on a quantum knife edge in a universe that appears against all odds to have been expecting us. But while the Big Rip presents a violent and dramatic end, a final shredding of the cosmic tapestry, the fate predicted by the fundamental laws of thermodynamics is far more patient, far more subtle, and in many ways far more terrifying in its absolute, inescapable finality. This is not an explosive end but an eternal sigh, a fading of all light, heat, and difference into a uniform, featureless, and frozen silence. This is the heat death of the universe, the ultimate victory of entropy, and it promises a quiet, cold, and endless grave for all of creation. To understand this chilling destiny, we must first understand entropy. In simple terms, entropy is a measure of disorder, of how spread out energy is in a system. The second law of thermodynamics is one of the most ironclad rules in all of physics, and it states that the total entropy of a closed system, like our universe, can never decrease. It can only stay the same or increase over time. In our everyday lives, we see this law in action. A hot cup of coffee left on a table will cool down, its heat dissipating into the room until it reaches room temperature. It will never spontaneously draw heat back from the room to make itself hot again. A sandcastle on the beach is slowly eroded by wind and waves, its ordered structure becoming disordered sand. It does not reassemble itself. This is the universe's one-way arrow of time, always moving from order to disorder, from concentration to diffusion. Now, scale this principle up to a cosmic level. Our universe is currently in a state of incredible, though temporary, order. We have vast temperature differences, the searing multi-million degree hearts of stars versus the near absolute zero of the voids between galaxies. We have concentrated pockets of matter and immense stores of usable energy. Stars are engines that fight this trend, converting concentrated hydrogen into energy and light, but they are ultimately fighting a losing battle. Each fusion reaction, each flash of starlight, releases energy that eventually dissipates as waste heat into the coldness of space, increasing the universe's overall entropy. Stars are not creating order, they are spending it. They are burning through the universe's finite supply of concentrated, low-entropy fuel that was gifted to us by the Big Bang. The heat death is the inevitable conclusion of this spending spree. It begins with the stars one by one. The massive blue giants will be the first to go, burning through their fuel in a few short million years before exploding as supernova. Then the sun-like stars, including our own, will exhaust their hydrogen, swell into red giants, and then collapse into cooling white dwarfs. The small, dim red dwarf stars will be the last to hold on, their frugal fusion processes allowing them to shine for trillions of years, but even their light will eventually, inevitably, flicker and die. With no new stars forming, all the interstellar gas and dust having been either consumed or expelled into the voids, the galaxies will fade from brilliant spirals and ellipses into dark conglomerations of stellar corpses, black holes, neutron stars, and cold, dead white and brown dwarfs. For a time, there will still be some activity in the darkness. The gravitational dance will continue. Brown dwarfs might occasionally collide, sparking a brief, final new star. Planets flung from their dead stars might warm slightly from the decay of radioactive elements in their cores or from the tidal forces of a close encounter. But these are the last faint embers in a cooling fireplace. Eventually, even these processes will cease. The universe will continue to expand, driven by dark energy, and in doing so, it will grow exponentially colder. The background temperature of space, currently a few degrees above absolute zero thanks to the afterglow of the Big Bang, will plummet toward absolute zero itself. This is where the true existential horror sets in. Absolute zero, minus 273.15 degrees Celsius, is the state of minimum possible energy. At this temperature, all motion stops, atomic and subatomic motion ceases. Chemical reactions become impossible. The universe achieves a state of maximum entropy, a state where energy is perfectly and uniformly distributed. There are no hot spots and no cold spots, no stars, no planets, no light, no heat. There is only a vast, black, incredibly dilute soup of subatomic particles and radiation, all at the same infinitesimal temperature. The cosmos becomes a static, featureless void, frozen in time. The most terrifying aspect of this fate is not the cold or the dark, but the eternity that follows. This is not an event, it is a state, and it is a permanent one. With no energy gradients, no differences in temperature or pressure, no work can be done. No thought can occur, no change of any kind is possible. Time itself, in any meaningful sense, may cease to have relevance. The universe will simply be. A silent, motionless, and endless equilibrium that will persist forever. Every triumph, every tragedy, every work of art, every galaxy, and every thought that ever was will be rendered not just forgotten, but physically impossible to ever occur again. It is the ultimate erasure, not by violence, but by an infinite, quiet, and perfect stillness. But if the ultimate heat death of the universe represents a final, irreversible end to all things, our final entry presents a terror of an entirely different nature. One that calls into question the very nature of our existence from this very moment forward. This is the simulation hypothesis, a brain-breaking idea that suggests our entire universe and every conscious experience within it might not be a fundamental reality, but an immensely sophisticated digital simulation, nothing more than lines of code running on the computer of a vastly advanced post-human civilization. The core argument, championed by philosophers like Nick Bostrom, is deceptively simple and rests on a few logical premises. First, it assumes that a technologically mature civilization would eventually develop computing power so immense that running conscious, detailed simulations of their ancestors would be trivially easy. Second, it assumes that such a civilization would have some interest, whether scientific, historical, or entertainment-based, in running a very large number of these simulations. If both these points are true, then the statistical probability is staggering. The number of simulated minds living in artificial realities would astronomically outnumber the number of original, biological minds in the base reality. Therefore, by pure probability, you and I are far more likely to be one of those simulated beings, living in a constructed past, than we are to be a rare, original human in the one true reality. We are almost certainly living in a simulation. The immediate, visceral terror this induces is the profound and utter loss of authenticity. Every cherished memory, every pain, every moment of love and triumph, none of it would be real in the way we believe it to be. They would be programmed experiences, data points in an experiment or scenes in a story written by entities whose motives we cannot possibly comprehend. The beauty of a sunset, the taste of food, the feeling of wind on your skin, all of it could be a perfectly rendered sensory input with no basis in a physical world. It reduces all of human history, art, and struggle to a performance, a ghost in a machine whose true purpose remains forever hidden from us. This leads to the second, more active layer of fear, the potential for intervention or termination. If this is a simulation, who is running it? Are we a scientific project studied by dispassionate researchers who might decide to end the experiment if the data becomes uninteresting? Are we entertainment, a form of immersive historical drama that could be cancelled by its audience or its creators when the ratings drop? The simulation could be shut down at any moment without warning, erasing our entire universe and every consciousness within it in the time it takes to flip a switch. There would be no protest, no appeal, and no way to even know it was coming. One moment we exist, the next we simply do not. This is an existential vulnerability far more intimate than an asteroid impact. It is the terror of being fundamentally ephemeral, a thought in a mind that could choose to stop thinking it. Some scientists and philosophers have even looked for potential glitches in the matrix anomalies that might betray the underlying code of our reality. They point to things like the seemingly arbitrary, fine-tuned constants of the universe that make life possible, which could be interpreted as set parameters. The oddities of quantum mechanics, where particles seem to exist in a state of probability until observed, have been suggested as a potential processing optimization technique, a way for the simulation to save on computational load by only rendering things in full detail when they are being looked at. Of course, these are just speculations, but the fact that they can be seriously considered highlights how deeply this idea unsettles our perception of what is real. Ultimately, the simulation hypothesis is the final, terrifying frontier of cosmic dread. It takes all the external threats, the black holes, the gamma-ray bursts, the dying sun, and internalizes them. The monster is no longer out there in the void, it is the void itself. The prison is not of space but of reality. It suggests that the greatest terror may not be that we are alone in the universe, but that we are not, that we are the property of creators who are utterly indifferent to us, and that our entire existence is contingent on their continued interest. It is an idea that, once truly considered, forever colors the way one looks at the world, leaving you to wonder if the stars you see at night are distant suns, or merely the perfect, beautiful backdrop of a cage we can never see and from which we can never escape. And so our journey through the cosmos's gallery of horrors comes to a close. We have ventured from the silent, predatory drift of rogue black holes to the silent, logical terror of the dark forest. We've witnessed the universe's capacity for instant, absolute erasure through vacuum decay, and its patient, inevitable execution of our sun's red giant phase. We've stood in the path of gamma-ray bursts, the universe's ultimate flashbang, and felt the isolating chill of the Boötes void, the great nothingness that defies explanation. We've been pulled by the unseen might of the Great Attractor, haunted by the singular, unanswered shout of the wow signal, and humbled by the perfectly tuned miracle of the triple alpha process that made our very existence possible. We've seen stars cast out as hypervelocity exiles, watched galaxies devour one another in acts of cosmic cannibalism, and trembled at the thought of magnetars whose starquakes can shake space itself. We've unraveled the chilling logic of the Fermi paradox and considered the spine-tingling possibility that our reality is but a sophisticated simulation. We've plotted the course of comets from the frozen Oort cloud and faced the silent, subatomic barrage of galactic cosmic rays that threatens our future among the stars. We've stared into the heart of neutron star collisions, the universe's ultimate forges, and contemplated the twin cosmic fates that await all of creation, the fiery, explosive Big Rip or the absolute frozen silence of heat death. And we've even looked upon a danger of our own making, the cascading prison of the Kessler syndrome, a trap of our own ingenuity. This tour of terror is not meant to paralyze us with fear, but to awaken us with awe. Each of these 25 concepts is a masterclass in cosmic humility, a reminder that the universe is not a peaceful, static backdrop. It is a dynamic, violent, and breathtakingly beautiful arena where forces beyond our comprehension play out on scales we can scarcely imagine. To understand these horrors is to truly appreciate the incredible fragility and preciousness of our pale blue dot, a tiny oasis of life and consciousness in a cosmos that is, for the most part, utterly inimical to both. Our desire to explore, to understand these terrifying wonders is what ultimately defines us. It is a refusal to be cowed by the darkness, a declaration that even in the face of such unimaginable power and mystery, we will still look up and ask, what's next? So we turn the question over to you. Which of these 25 terrors haunted your thoughts the most? Was it the existential dread of the simulation hypothesis, or the more immediate threat of a quasar's death beam? Let us know in the comments below. Share your cosmic nightmares. And if you're ready to continue peering into the abyss, make sure to subscribe and hit the notification bell, because our deep dives into the universe's greatest mysteries have only just begun.